So in this video we're going to deal with limits to prove using the parabola. The other one, previous video, was a straight line, but now it's a parabola, so it'll be different. Now this proof is very complicated, so memorizing is key, not understanding. Okay, so the first thing you want to assume something. When we're always doing proofs in limits, we say that the absolute value of x and then minus the what we're is going to approach, it'll be less than. Now in dealing with this, we say it's less than delta. So delta is like this s, and then we also say x squared minus 4, it's less than epsilon. So it's x squared minus this. Now x squared minus 4, we can rewrite this. Okay, so we'll just rewrite it. So we can say it implies, or we can just put it down over here. So x minus 2 and x plus 2, and this will be less than epsilon. Now after you do this, I want you to go to this first equation you created and basically somehow change this s. Now it might not make sense, but what you want the s to be is 1, because s over here, basically the distance of this whole thing has to be less than 1, has to be the closest to s. So it'll always be 1 when doing this proof. Now this can be rewritten as minus 1 is less than the absolute value of x minus 2, which is less than 1. Now you might think, why are we saying minus 1? It's because if you're dealing with an absolute value, that's a law. You can't change this like this, because an absolute value of a negative and a positive will produce the same result. Now basically now I got x minus 2. I needed to get to one of these over here. Now I want it to get to x plus 2, this right one over here, x plus 2. Now I wouldn't want to get x minus 2 because I got x minus 2, but I wanted to get to x plus 2. So I'm looking over here. If I say plus 4 in the middle, plus 4 on the right, plus 4 on the left, I can make it what I want, right? So that being said, I can say 3 is less than x minus 2 plus 4 is plus 2, which I wanted, which is less than 5. Okay, so now you can put the absolute value same over here, but it really doesn't matter because it's between two positive numbers, so it'll be positive no matter what. But we can put it over here, no problem, because the next step we are going to need it anyway. So now basically what I want is I want x plus 2, right? Now the thing is over here, it's called the biggest number. Okay, so just remember this, you have to take the biggest number, which is 5. So ignore the 3 and just put x plus 2 is less than 5. Now it might not make sense, okay, it might not make sense, but there's a big reason why you do this. So just put the is less than the biggest number, which is in this case, so you just ignore this 3 and less than sign. Now what I see very, very clearly is x plus 2, I got x plus 2 over here also, is less than 5. So I want you to look at 5, right, and just replace 5 with this in this equation. So now if I do that, I get 5, which is this, times the absolute value of x minus 2. So times the absolute value of x minus 2, and that be less than epsilon. Less than epsilon. And then I do not want 5 over here, because at the end of the day I want the absolute value alone. So that is x minus 2. The absolute value of x minus 2 is less than epsilon over 5. Now if you see what I did here, it's simple. Now when you're done with this, this is 50% of everything done, right? Now you need to do something that is very, very confusing and something that took me quite a while to understand. So just memorize, don't understand, because then you'll go mental. So okay, so we're done with epsilons over here, right? Your last thing was proving some type of epsilon. So now, this is, epsilon. So now let's do delta. So what I want you to do is say choose delta minimum, and then put up brackets over here, right? Minimum. Now where do you get this minimum values from? Okay, we're looking at delta. Where we had delta over here, right? We made delta over here to be 1, so put 1 here, And where else we made delta? Well, think about it, right? Over here, technically this is delta. This is equal to delta because x minus 2 and x minus 2 over here is the same, but this is less than e over 5, epsilon over 5, and this is delta. So technically, in fact, I should put it over here in my proof that s, which is epsilon, no, sorry, it's delta, is equal to epsilon over 5. I should have actually put it over here after this over here, right? Because that's my conclusion. This is equal to this. So because I said I made this delta 1, okay? I made it 1. I also came to know that the same thing over there is epsilon over 5. You see, it's exact same. This is x minus 2, this is x minus 2, this is x minus 2. So this and this and this are equal. So I made it 1, right? But what other number I made it? I made it epsilon over 5. So basically, to translate this, I'm basically saying, okay, choose s. But I need to choose delta to be represented as numbers. That's why I said minimum 1, which I picked, and e over 5. Epsilon over 5. Now here's the another part. Now you say so. So what? So s, which is delta, is less than this value, and delta is less than and equal to this value. Doesn't make sense, don't worry, just memorize this. Now you do the conclusion. So the conclusion is basically writing your introduction, which is this over here. So you say then, okay, now I'll say x, the absolute value. So the absolute value of x minus 2, it's less than delta, and then I'll write my other one. Now I can write x squared minus 4 or x squared, it doesn't really matter, but I mean, it doesn't matter because both of those are the same. But let's say x squared minus 4. Okay, now in the they want it, I think, simplified. So maybe after you do x squared minus 4, you go and show it's also equals to x squared minus 2x plus 2. So it's less than epsilon. Now what you want to show is this. So basically now we have a problem, because s over here, which is delta, is not the same as this. So basically I want to make this delta, because remember, everything I'm doing here is considering like delta, which is the main person. So what I want is basically what I can rewrite epsilon as like, you know, with the reference s. Well, if I look at over here, this equation, I can rewrite epsilon over here as 5 delta 5s, see? So I can rewrite this. So let's see, so I'm going to rewrite it over here. So x squared minus 4, the absolute value x squared minus 4 is less than 5s, and you know s is delta. And now here's the fun part. Now if this works, then that means the proof is correct, which is less than. Now what is 5? Okay, so 5 times s, what is s? S is epsilon over 5, so you write that, times epsilon over 5. And what you know it, 5 cancels out with 5, so it means x squared minus 4 it's less than epsilon, and you proved it, see? So you proved it by just using this epsilon, we can get to this final answer. So this is the answer, how you do it. It's a little bit complicated. You have to memorize it, there's no other way. Don't understand it, you go mad. Yeah, so that's basically it for proving these limits.